everybody. Thank you very much for joining us here today. This is Paul Taubman with 9.Connects. You are in the right place if you are here for our webinar today on improving the Altium ECAD MCAD connectivity experience. So just a couple of housekeeping notes before we begin. First and foremost, this is going to be a very interesting webinar. It's something that we've never done before, but I'm actually going to have a co-presenter today. So I have with me on the line Tom Cassidy. So Tom, if you want to say hello there.
Hello, everybody.
All right, so Tom is also one of my colleagues here at 9.Connects. He's actually over in Houston, Texas, and we wanted to do this from a distance to show you this process that we can do through this thing called the SolidWorks Connector, and we'll talk a little bit more about that as we go about. Now, as for questions, we believe there'll be plenty of them today, so feel free to write those questions in the questions box of your panel. We also have on the line, he's the man behind the scenes. His name is Christopher Che, and Christopher is just as knowledgeable about a lot of these things as we are. If you can't answer it, then we'll certainly try to get to it during the Q&A session at the very end. So feel free to write those questions in, and he'll try to answer those if he can do so, and if not, we'll take a look at them at the end of the presentation. So our agenda today, we've got quite a bit of things to look at. First and foremost, we want to talk about understanding the flow between ECAD and MCAD, and just take a look at what are we doing right now and where do we think things need to really go to make it a more efficient process. We're also going to give an example of why importing and exporting is a very limited way of doing things. You may be really surprised that even though this has been a really big step forward, it really needs to take another big step forward in terms of how we can easily communicate things to and from. We'll also look at the SolidWorks Connector, and we're going to look at its flow from the ECAD to the MCAD side and also from the MCAD to the ECAD side. Now, I'm also going to talk about what I'll call a couple of notes of interest. We had the opportunity to meet with a couple of companies over in Connecticut last week, and I got to be honest with you, I think even though there's always a lot of focus on Silicon Valley, there's a lot of mechatronic design that is going on in Connecticut, or this is straight up mechanical design. So we got to talk to a lot of them there and also present and talk to them about the SolidWorks Connector, and they gave us some feedback as to the things that they would like to see with it or if it can do it. And I want to address those before we get into the Q&A. And of course, we'll also try to get into some Q&A as well. So before we go any further, we do have a polling question for you, and we'll get that up here on the screen here. The question is, we'd like to know who designs the board shape in your organization. Is it on the electrical side, the mechanical side, or is it coming from either side? So take a moment to click on that. And what we're seeing over here, it's actually really an interesting thing. Actually, very few of them actually come from the electrical side, only 7%. Almost 51%, well, basically 51% of you said it's coming from either side of the equation, and that actually 42% of them are coming from mechanical. So that's actually a very interesting poll result, given that given the fact that many of us are coming from the electrical side of things. So we're already starting to embrace the mechanical aspect of it and having it assist us with our mechanical design. So that's a good thing. All right, this thing I've just thrown up onto the screen over here, it may be a little bit of an eyesore, but bear with me because this is where I think a lot of confusion comes in. We have the ECAD side, things like Altium Designer, SolidWorks PCB, and we also have our MCAD side as well, which is what we call SolidWorks or SolidWorks CAD. And a lot of times we're trying to figure out, well, what is this whole interface server vault thing that we keep hearing about that allows us to link between the ECAD side and the MCAD side? So I wanted to draw it out to show you the different paths that you can take. So let me just go through these very quickly so that you kind of have a feel for it. First and foremost, as we demonstrated back in July, there is a product called SolidWorks PCB, and it is powered by Altium Designer. So SolidWorks went over to Altium, and they partnered on a version of Altium Designer specifically for really for mechatronics design. And if you want to get more information about that, again, take a look at our webinar back in July. Now, if you were to purchase that, it automatically comes with a piece of programming called the SolidWorks Connector. Okay. If you're an Altium user, and that's what we're going to demonstrate here today, you need also a way of connecting into SolidWorks as well to take advantage of this. So you have an extension that is called the Altium Designer Connector. Now, this is a paid-for connector. If you go into the updates and the extensions that Altium Designer has, you'll see it there, but once you download it, it's going to prompt you for a license. So that's something that would need to be purchased. Now we have to have some type of server here because this is kind of handling what you could say the version control between the ECAD side and the MCAD side. So if you already have a vault, that'll work just fine. However, if you don't have a vault, you don't need to purchase one. What you can use is something called SolidWorks Services. And from what we can see is it doesn't require any type of license. It's just something that you download. So whether you have SolidWorks PCB, which comes along with the connector, or Altium and you purchase the extension, you can get access to the SolidWorks Services. And then lastly, of course, you do also have to have SolidWorks, or in this case, we'll call it SolidWorks CAD. What's kind of an interesting thing about the nomenclature is that everybody, when they mention SolidWorks, especially on the mechanical side of things, they instantly think of the CAD program, where in our case, there's a number of different other programs and features that we have to kind of call out by their individual names. For our purposes today, we want to show you the path. So what I'm going to do here is I'm going to show things in Altium Designer. I do have the Altium Designer connector already installed, and so I'm doing that here from my office here in San Diego. We have a server set up in Austin, Texas, and that's where we are hosting our SolidWorks services. So this is the services that I will use to communicate, and this is also the one that Tom will communicate on his end through SolidWorks CAD, and Tom is in a suburb of Houston, Texas. So this is what we're doing. So we're actually doing this in real time halfway across the country. So we wanted to show you that this is not just me doing this on one machine, but we're doing this with two people on two different machines in two completely different locations. So just a very quick overview, what are we actually pushing back and forth? We are pushing back and forth a project that we created here at 9.Connects called the Rangefinder. And you've probably seen it in other webinars. However, we continue to refine it because there seems to be more and more use cases that we can make with it. And what you see here on the left is basically our board. This is the Rangefinder board, which we developed. This is a mega board. This is basically a controller board. It's an Arduino type board that you can purchase. And then lastly, you also have this ultrasonic sensor that we have here. So when you see them all connected together, this is what it looks like. And just to let you know that it actually does work over here, I put together a little bit of a video so you can watch it as it's going through its motions here. So it's an ultrasonic distance sensor. It has a temperature sensor on it as well, and it's got a 2-line 3 RGB display. So when we initially created this thing, it was specifically for our PCB fundamentals class. However, now that we are also working with SolidWorks, we said, okay, maybe it's time for us to build an enclosure for this as well, and that's where we're going to focus that. So with that, before I do anything else, I'm going to ask, there's 2 polling questions I'm going to bring up. And be careful of the wording on this. The first polling question is going to ask you from which side, and when you're transferring a board, it's going to ask you if you're doing it from the MCAD side or the ECAD side here. Hold on, I got to extend it on my line here. So we're going to ask you from each side of it. I think the first one asks if it's coming from, can't see it because it's shortened up here. And you guys see the poll. I don't see the, I see the answers, but I don't see the question.
It's coming from the MCAD side first.
There we go. Okay, so we're asking, the question is, if you're getting it from the MCAD side, how do you push it back and forth? Thanks, Tom. Okay, and then we'll show the, we're showing the poll results over there. So 91% of you guys are doing it through, I'll call traditional methods of either IGES-STEP, DXF, or IDF. So you guys are using the traditional ways of passing these things back and forth, which is what we would kind of expect. I didn't realize 91%. Some of you guys are doing some type of interface tooling, and at this point, there's a small percent of you who aren't using it. So we're glad you're here today because hopefully we can convince you that the connector might be of something of interest. Now we're going to show you the second poll here. And Tom, since you can see it on your screen, do you mind reading it off?
It says, when transferring a board representation to ECAD, which format method do you use?
Yep. And you can see that when you're going backwards, I should say backwards, when you're going from the ECAD side to the MCAD side over to the ECAD side there, it's a little bit different. So we seem to have a mechanism, generally speaking, of pushing things from the ECAD side to the MCAD side. But when it comes to going to the MCAD side to the ECAD side, either you're using the same things or you're just not doing much of it at all. So it might be just a one-way street for you. So that's what we want to take a look at here now. So I'm going to escape out of the PowerPoint presentation, and I'm going to show you what we've got on the screen over here. So what we're doing is we're actually showing you 2 screens. What you see on the left side is Altium Designer. Again, that's on my machine here. And what we're doing is a Skype call through to Texas with Tom. So Tom's showing our screen over here as well. So what we want to do is talk about this idea of importing and exporting files, which is the method that we've been really using for the last decade, and it's served us pretty well. But there's kind of an inherent flaw in that. And the reason why it is because we do have things that look graphically the same to each other, but when we actually bring them in and we want to have something that's got some intelligence behind it, that's where both sides suffer. So what I'm going to show, for example, is a push from Altium over to SolidWorks, and then show you the results of what happens when we push back from SolidWorks back into Altium without any connectors. So the traditional method for us after we've got something over here is we'll go into File, Export, and then we're going to use something like Parasolid or Step, the Step file. And there could be other ones that you're using as well, but let me just push it through as a Parasolid, because believe it or not, Parasolids are actually very native to the SolidWorks CAD program. So when we do that over here, it's going to ask us for some things. So we're going to save it off, right? And this is the extension that you see over here. And I'm going to cancel this out over here, but and I'll show you some of the options later on. But the idea behind it is that we would go into that file, we'd go to that Parasolid, we would save off our design, we would somehow try to get it over to the MCAD side. So what are those ways? We could email it if it's small enough. We could do it onto a common directory if we all know where to look for it. And then we can also do it through an FTP transfer site. So regardless, that's about let's say a 5 to 15 minute exercise that we need to do in order to get it over to the MCAD side of things. So now what I'm going to do over here is Tom has actually brought in the Parasolid. So we wanted to save some time here and not have to go through that whole thing. But what he did was he took in a Parasolid I made earlier on prior to the webinar, and he's now brought it in. Okay? And we can see it comes in, and graphically it looks great. But what I want to focus your attention on is the left side. And if you're not familiar with SolidWorks, SolidWorks basically works in two different types of entities. I don't want to call them primitives because it's not really primitive. You either have what's called an assembly or you have a part. And if you're looking at this onto the left side, what this did was it came in as a bunch of assemblies. Okay? So graphically it's fine, but in terms of its intelligence to make use of it in the traditional form of looking at, let's say, a component, it didn't really come as a component. It actually came in as three separate entities. So in this example, it came in as three separate entities. So when Tom brings this capacitor in here, you can see as he's clicking along here that capacitor is actually made of three different parts, okay, which makes up this assembly here. And the reason why that's important is because yes, you can put this in, and if you're just going to use this as a whole into some larger chassis or an enclosure, that works just fine. But if he wants to move things, that's not going to be easy to do. You know, we just want to be able to click on it and drag it. And the way it's set up right now, it's just not able to do that. So this actually results in a lot of effort on the mechanical side to correct these things or to turn these into what we would think of on the ECAD side as individual parts. So that's the first issue that we've got. So there's a lot of work on that end on the ECAD side to make that work. Now, let's say that all that work is done. They can push us back a Parasolid as well. So what good does that do us? So let's take a look on the Altium side of things. So I'm going to bring back Altium here. Okay, so if I'm an Altium designer and I want to bring in what the mechanical engineer has done, well, first and foremost, I really can't bring them in as individual parts unless they send them to me as individual parts. But let's say they said, hey, I modified your board, take a look at it. So for me to bring it in right now without using a connector, I have to go into a Place 3D Body. Okay, so I'm going to go into Place 3D Body, and I'm going to use the generic 3D model here. And just as a side note, if you didn't know about this, when you load from file, recently Altium added in a couple of other ways of bringing in files. So in addition to the traditional step, you can bring a Parasolid in, and you can also bring in a SolidWorks part file as well. So I'm going to bring in what Tom did. So again, we set this up earlier so we didn't have to go through this rigmarole of having to transport and send files to each other in different locations. So we're going to press open. And we can see our board, and that's just great. And we are going to bring it in at this point in time. Okay. And we'll cancel this over here because it's prompting me for another part. So when I zoom in, okay, you'll notice too that I have no ability to basically grab any of the stuff that's in here. All these things are it's just one entity. It's just one representation. If I hit my 2 key to look at in the 2D mode, then it's just simply on a mechanical layer. Now, one of the things I could do with this, okay, for example, is let's say I move some things. I want to see if they move some things along the ways. For example, if I take this mounting hole and I move it over here, we'll push it up over here, then I can go into my 3D and I can take this here and I'm going to actually change its opacity quite a bit down here. I'll press OK, and then I can try to match this up. Okay. It won't be perfect here, but the idea behind this is I can see where the original hole is and the current hole is. So if I wanted to try to do that just to see what the differences are, I could do that. However, keep in mind this is a pretty simple board. So if I got a lot of these things moving around, that's not going to make a whole lot of sense. And plus, it's a lot of work too. If someone on the mechanical side's already moved it, well, if it came in, I would want my board to move along with it as well. So we're not both trying to update at the same time on an individual basis. So you can see that, yes, this method of pushing things like parasolids and steps in the other files does work, but it definitely has its limitations. And that's what leads us over to this idea of the SolidWorks Connector. Okay. So what we're going to do over here is to introduce you to that. So I'm going to, first and foremost, I'm going to, Control V, go to the two button over here, and I'm going to just take that parasolid and delete it. Now, for us to use the SolidWorks Connector, we have to set up what's called a managed project, and that's something, again, we did here beforehand. To set up a managed project is not that difficult. As a matter of fact, it's the same way you'd set up any type of project. So if I go into File, New, Project here, the major difference that you're going to see here is that if you do have the services set up, it's going to know where your services is located. It's going to want to create a repository folder for it. You'll certainly need a checkout folder. If you're not familiar with Subversion, by the way, certainly look at our prior videos on it. We've covered this somewhat in depth. So the idea behind it is you need to have a repository location and you need to have a checkout for it. But the other thing that you need to know is declare it to be managed. So now that it's going to be managed, it knows that, hey, in addition to it being local, we got to make sure that the server knows about this as well, that PCB server that we're going to be communicating with, along with the SolidWorks CAD communicating with it. So that's our interface. So we're going to press, OK. Actually, I'm not going to OK this because I already got it set up. But it would basically create up a PRJ PCB file, and that's when you would add your files to it. So again, we've already got this kind of ready and going for you here, just to keep track of the time here. Now, once we've got this and we've brought this up and I want to push something over for the MCAD side, then I can click on this panel that is called SolidWorks PCB Connector. Right? And I have the ability to pull and I have the ability to push. And as we go along, you'll see the differences of it. Also, you'll notice kind of this large blank area. As we send messages to each other, you'll see that those messages will be there and they continue to be there. There's no way of erasing those messages. So it gives us a verbal history of the communication between the ECAD side and the MCAD side and vice versa. So what I'm going to do is I'm going to push this over, okay? And all it's going to do is prompt me, and I'm going to just call it the initial release. Okay, and I'll post it. So what it's doing now is it is contacting the server in Austin, and it's basically taking my information over here and it is putting it into a format that is going to allow SolidWorks CAD to pick that up. So I'm going to split the screen here, and now that we've got this pushed in here, the only comments I'll make other than that is that notice that that's all I had to do. I really didn't have to send out any files or anything like that. The services handle that for me. So I'm going to now expand out Tom Cassidy's screen here. So he's in SolidWorks CAD. Again, he's in Houston. So now he's going to pull in what I just did on my side. Okay. So what he's opening up is the SolidWorks PCB add-in. So this is an add-in file that you have, and you'll notice that it looks very similar to the one that we've got on the Altium side as well. Okay. And he's closing up his, he was just closing up his last file. And so what he's doing here is he's going to be now pulling the board from the PCB services. Excuse me. And he has to log into it as well. We've been using several services. Some of them are local on our machine, and then this one here is the one that's going through the Austin server. Okay. So you can see we've got a number of projects here. So we want the the one that says webinar project. Yep. We've been practicing. So go ahead and press OK. So what's happening now is that, keep in mind, we don't, in any type of repository, we don't work in the repository. The files that you saw me working on were local to my hard drive. And what he's doing now is he's actually creating a directory so that he can put his files onto his hard drive as well. So yes, there is some tracking that's going on through the services, but again, generally speaking, in any type of repository, we never actually work in the repository itself. We always work on checked out files, and that's what it's handling here for us. So what it's doing now is it's pulling things in. It's going to take a little bit because it is rendering each one of these, each one of my components into a part on the SolidWorks side. So it's not just pulling in a bunch of assemblies, it's actually trying to treat these things as parts. So it is taking a little bit of time. So don't worry about the not responding, it's just taking one component as we're going along. What we're seeing here is now the board is being shaped out. And on the left-hand side, we also see each and every single one of our parts. Now, if you remember what it looked like, if you look where my cursor is on the top left corner, you'll see that that's called an assembly, right? It's got that little block on top of the part. But if you look at everything down below over here, these are all individual components. So if Tom now grabs any one of those components on his board and moves it around, it will move around very easily. So all that work of trying to convert these things from assemblies into components is done for you, so you can see the motion of that. What's also nice about this is that we can go the opposite way as well. So now Tom has this into his, he has this on the CAD side, and if he wants to move things and propose some changes, he can do so. So the three things that you can change is you can change the board size, you can move components, and then you can also add and modify board holes as well. So what he's going to do right now is he's going to move a couple of components. One of them is the switch, and the other one's going to be the H4 header, which holds the sensor. So he's proposing these changes for consideration to the ECAD side here. So once he's made these changes here, he has to make a push over to the server so that I can see it. So once he does that, I'm going to split the screen here, because what you'll see is that once he actually pushes this over, I'll be notified of it, as long as I have this particular panel up and I'm in this project. So he's typing in his comment there, and then he'll push it. Okay, and you can see on my side here, so I'm going to go full screen on this, and I'll close this one out here. So what we've got over here is that we've detected some new changes. I certainly want to view those changes, so I'm going to click on that. So it's pulling in from the server the specific changes, and we can see what was pulled in. So the H4 header and the switch was pulled in as well. So if I have a really large board and I have no idea where those are, and I could do a jump component or do a quick search for it, but it allows me to see it very quickly, because if I just click on it, you'll notice it's moving into position, the proposed position. If I go over here to SW1, you can see this one got moved down. If I want to see it again, it's just a matter of clicking off and then clicking it on again. So I can see it definitely in 2D. If I'm having a hard time seeing it 2D because I got a lot of layers on, I can always hit the 3 key here, and I'll center this up a little bit. And again, I can show this, and now you can see this in action. Let's click on that. I won't accept it. I want to just show you moving it. Okay, so we've moved that here, and if we click on SW1, we can see that here as well. Now, one of the things that ultimately is going to happen is we may not always agree with the things we want to have moved. So we want to show you what happens through this acceptance process, because for me to just accept it and be done with it, that's only a part of the story. That we always have to keep in sync with each other. And the ECAD side kind of rules that synchronization process. So let's say I'm perfectly fine with the H4 being moved, but I'm not keen on having the switch moved here for whatever reasons. So I am going to press accept at this point. Okay. And what this has done is just simply accepted those changes on my side. This has made no impact whatsoever on Tom or the MCAD side of things. Okay. And we can see this here. But in order for us to kind of complete this circle over here, I actually have to push back the approval. Okay? And that's what I'm going to do over here. And in a sense, I'm also pushing back a disapproval. So I'm going to push this, and I'm going to say accepted H4 cannot move switch.
Go ahead and split screen.
So, yeah, I'll split that screen, thank you. So you can see what happens here on Tom's side when we do that. So I'm going to post this now. So again, it's hitting the server and it's pushing those updates. And then we look on Tom's side over here. In a moment here, it will pop up and say, hey, you've got an update. There it is. So I'm going to make you full screen, Tom.
Okay, so I'm basically going to do the same thing on my side that Paul did on his. I'm going to view what he suggested I change. And as you can see, I have something very similar. Oops. Let me lock that down. So, okay, so I can say, what did he do? So you can see my switch is now moving, and he's actually undoing what I did. So he's saying, no, I don't like that, put it back where it was. And then he's saying, okay, yes, your H4 switch is okay. So in order for me to be in synchronized with him, I have to accept both of his operations, even though I'm accepting a rejection in essence. So I'm saying, okay, I accept the fact that you rejected my switch move, and I accept the fact that you accepted my H4 move. I hit accept, and you'll see it does its little thing, and it should end up looking exactly the same as Paul's project.
Yeah, in fact, I'll split it for just a moment so we can see that. So if I go here and you view fit, and then you can see that these are in the exact same place again. So, and again, we can do this pretty much all day long. We can push, in summary, we can push those components, we can change the board size, we can add holes to the board, we can remove the holes. And so by doing this, this allows the MCAD side to basically put things together. So what we wanted to do, and so in addition to doing this webinar, we also wanted to do this as a proof of concept to create an enclosure for for this rangefinder over here. So what he's going to bring up is kind of the results of this ability to be pushing things back and forth.
Right, so typically I would get a board from the ECAD side and build something around it. So let me just show you a project I already did, and also show some examples of why you need this kind of a collaboration. So the initial design of the circuit board, as Paul mentioned, was not intended to be put into an enclosure. It was just a sample board, touchy-feely for our classes, so it didn't really take into consideration any issues that might arise trying to put it into a box. And as a mechanical engineer, the first thing I noticed was, if you see over here on the right, the sensor circuit board is much higher than the level of the LCD. So there's no easy way to put that into a box with a flat top. So I had to deal with that by actually coming up with a rather weird dip in the box. So I could get down to the LCD while still supporting that. And then just another few other items, the buttons that were placed on the circuit board were not placed easily accessibly on the outside. So I had to come up with a plunger arrangement to be able to push those buttons and extend them up to the top of the case where it now is. So as you can see, it's one thing to throw things back and forth, but being able to see something like this right off the bat would have potentially made the design of the circuit board and case a lot easier, a lot more synchronous.
So the other thing I want to bring up here, and we'll demonstrate this, is that, at this point in time, the board's already been produced, and so what Tom's working on is a current revision. And that's what you're seeing here as a result of what we had already done. Now, if Tom later on says, okay, I really want a new revision outside of what we're doing over here, and I want to propose that board, there is certainly a way to do that, and we're going to just demonstrate that here very, very quickly. So what we're going to do here is we're going to close this up here, and we're going to show you how we would start a new revision of the board. So we're going to close this here. Okay. So we're back to basically a bare screen. We still have our add-in panel up here. So what Tom's going to do now is he's actually going to create a new board.
So you see up in the left-hand side, there's, in addition to pulling a board from something, you can also create a new board assembly. So that'll be the first step. You press that, and it's going to ask me to either select a project that's already there, or I'm going to actually create a new project. I'm going to call it and this will create a project on our server, and then it will also, as you will see, create a default circuit board, which is very similar to what Altium does. And as always, you need to store it locally, so I'm going to select a local directory and save everything there. It's going to go through its thing, and now it comes up with a generic circuit board. And one of the reasons it does this is this isn't just a model in SolidWorks. It actually has some properties that SolidWorks and Connector use to pass information back and forth. So I couldn't just create a box here or a board and have it work. I have to let it apply these properties initially. And like I say, it's very similar to how Altium does when you create a blank PCB. So what I'm going to do is I'm going to go in here and I'm going to edit the sketch and kind of make it a little different. Long and thin, this is a quick and dirty way of doing it. Okay. And now you can see up in my PCB connector page, it says the associated project is the project I named, and I'm going to do a push and say this is the initial board.
In the meantime, I'm gonna split screen us here, because I want to show you what's not going to happen here on Altium. Go ahead.
So I'm going to post it, and as Paul just hinted, it's not really going to show up on the other side yet because we haven't connected the second leg of the journey. So anyway, as far as I can see, I've posted it, and since it's a new project, I have to somehow let Paul know that I've done that. So Paul, you can go ahead and take over.
Right. So what's happened here is notice that nothing came up on my current project because this has nothing to do with it. When he created a new board, he also created a new project or new repository folder for it. So what I need to do here is pull it in. So yes, there'll have to be a little bit of an email communication. At least he doesn't have to push a file to me. So what I'm going to do here is I'm going to go into File, and I'm going to go into Open Managed Project. So this is going to give me access to all of those here. And I believe it's the top one here. Yeah, I believe it's the top one here. And yes. I'm going to press Open. Okay. And let me go back over to projects, because keep in mind, he did everything in SolidWorks CAD, and that's not a format that Altium necessarily knows. So there's information in there that it can extract, but it knows nothing about a PCB doc. So I do have my new project over here where I can add in my documents. And what I'm going to do is I'll right click on it and I'll say add to project PCB. Okay, so it's going to bring in a brand new PCB at this time. So this is your typical, was it a 4x6 inch board that we have over here. But over here in my SolidWorks connector, because I'm now in that project, it says, hey, there's a proposal that's being made over here so I can view the change. So I'll bring that in. So notice that there's a board outline. And if I want to see what the board outline proposal is, I can click on it and it will flash it to me. And of course, if I accept it, here we go. Now I've got my new board. And at that point, I can continue to add my components on and then push those over to the MCAD side. So our project is already there. Also, again, keep in mind that we've got to go full circle with this. So what I need to do now is I need to push this over and say accepted board.
Don't forget to split screen.
Yep.
You have to save it
right.
first.
I've got to save it. Yeah, that's right. There's a little caveat there, and then I'll split the screen there. So let's get over to my projects, and we will do a save all here. So we'll do save project, and we'll save it here. That's fine. And we'll just leave it as PCB1. Okay. And then I'll also push it into version control as well here, just to make it a complete thing. So here, just initial release. Okay, we got that there. So that should make it all copacetic, and then we'll push it over. So let's go on over to our SolidWorks connector panel again. We'll do a push, call this one initial release. And then we'll post it. And then, oops,
I didn't split screen.
Yeah, unfortunately, while it's going, there we go. So I did split screen in just in time before it locked it up, and now there you go. It did come up on to Tom's side. So I'm going to do a full screen there so you can see that Tom now just can view the changes and accept what the ECAD side had protected.
And just to reiterate, as Paul mentioned in the beginning, this is all driven by ECAD. ECAD owns everything. MCAD can modify the board, but ECAD owns it. So even though I've pushed a design and said this is what I want, I have to take in what he said if it's okay or not. So I still have to accept and pull back his design. We have not synchronized up yet. So basically I'm looking and saying, yes, he's okay with that. I have to accept it. And if you watch right now, it's kind of a gray color, but once I accept his board, it turns into the green that he picked. And so now we are in synchronization. I've got board, he's got a board, and we're back to where we were at the beginning of the webinar, where we can start making changes and sending things back and forth.
Yep. So there you go. So you can see what the connector is like. What I want to do is I'm going to throw back up some of my PowerPoint slides, because there's some common questions that that are going to be asked, and we want to address those up front. So let me go back over here to this. So there are what I'll call 3 notes of interest. A lot of times people are asking about mechanical items. Can I push enclosures? Can I push over heat sinks, screws, those type of things? And not right now. However, it is definitely slated for the SolidWorks Connector 2018. So it is very much forthcoming. It is on the top priority of SolidWorks to get this to work, because obviously without being able to push over things other than the board and the connectors, you're a little bit limited. So, but they're very aware of it. You still can push things through individually, which we've traditionally been doing, but again, it's just a lot easier when it works through the connector, and that is forthcoming. So the other thing I want to mention too is there's a lot of people doing flex rigid. I think a lot more than we actually ever anticipated. Again, we went to our trip last week and we talked to 3 companies and met with a bunch of engineers at Unitech's Customer Appreciation. We met a lot of mechanical folks and they're very interested in this, but every conversation almost inevitably went towards flex rigid. Anytime we talked about mechatronic design, we talked about electronics and mechanical trying to work together. So it's not currently being pushed through the SolidWorks connector, but they definitely have this slated as a high priority. So hopefully we'll see that here in the very near future. And that's, I'll make that comment down over here. Now, what I did for you guys is to show what happens if you actually push it through. So I took the Bluetooth Sentinel, which is an Altium example, yesterday. I said, okay, let me push this through so I can at least show a picture of what they'll get. And yes, you will get it. So you'll get the board outline over here, and just understand that it's not able to differentiate yet between a solid area, or let's say called the rigid area, and the flex area yet. My understanding is that if you're somewhat familiar with bending of metal, sheet metal, I guess you can use that concept to do this over here, but unfortunately at this time you can't really pass that back and forth. But from others I have talked to, the idea that you can get the components at least put in there, and you get the board shape put in there, and if you can bend the metal, then you can at least provide the bend radiuses back over to the ECAD side, unfortunately through email at this point, but it's still a very doable process, and it's a lot faster than what you may have had to do in the past. But again, we're eagerly awaiting this capability. So it's not that unfortunately it's not there, but it will be there soon enough. And then the last thing is, let's talk about copper, because copper is always an interesting creature. It's not pushed by the SolidWorks connector, which is probably something you witnessed when we were doing this stuff back and forth here. Okay? But it can be pushed by exporting a parasolid. So in fact, we'll demonstrate that here in just a moment. And the biggest thing we always want you to do is question the why on that. Because if you're just trying to push it over for aesthetics, you're pushing over a lot of information that's just really nothing more than just for really pretty pictures. Because always remember that really the primary reason we're pushing stuff back and forth is for this concept of fitment. Can we fit this in the design that the MCAD side is putting together? And then the second part of that is, and this is a very useful thing too, is that if you want to see where the pads are, in relationship to the components, it may be useful also to pull in the top layer, the bottom layers of the copper to see where those pad placements are. Now, if you're trying to pull it over for thermal, you got to understand something, that SolidWorks simulation doesn't really care necessarily about the placement of the copper per se. It's more interested on the percentage of copper that you have, and that's inaccurate. Because obviously there is going to be copper that's going to be used for thermal purposes, especially maybe your planes or areas where you've got a really large FPGA that's really pumping out the heat. But generally speaking, the signal copper itself, which takes up a good portion of that copper, isn't necessarily also dissipating heat, because signals generally don't run that hot. So just be careful of that. You can run these thermal things on there, but you may not get necessarily an accurate response to that. So what we wanted to do is just at least show this to you, because we know this is of interest to you. So here's an example that we did, and we'll show you the live one here in just a moment. But when we did it, it was over 500 assemblies. It took us well over 10 minutes to actually port it from Altium over to the SolidWorks side. And there'd be a lot of post cleanup if we wanted these to act as parts here. So I'm going to escape out here for a minute, and now you can see Tom's screen, and this is really what we brought in. Okay. One of the other things that we also did when we did this is we actually removed the not only the silk layers, but we removed the solder mask layers. So it was a lot easier to see, because again, this copper is actually buried below that layer. So if you brought it in, you may not even see it until you either make it opaque or you just remove those layers altogether. So you can definitely bring it in through the parasolid. And the big question is, have a purpose for bringing it in, because you can see the amount of information that you're bringing in by doing this. And this again is a pretty simple board, and that was already 12 megs. So you can imagine what it would be like if you've got a pretty large board that's got thousands of traces and components on it. So you got that there. Now, I promised you guys I'd also show you what it looked like in Altium Designer. So just if you're curious to know, you'd go into File, and you would go into Export. All right. And then from the export there, you would pick on Parasolid. Of course, it's going to ask for a place to save it. I'll save it here for now. That's fine. What I wanted to show you is the export options. So make sure you look at this export options carefully here. So you can export the copper only. And we didn't try it for multi-layer, but for a 2-layer, it did bring in the top and on the bottom, which for our purposes, we thought that was pretty good. If you need to bring it in by layer, you can do so, okay, but it has to be on a signal layer. It looks like we can't bring in mechanical layers on this because we do have a number of mechanical layers set up on our boards. And then, of course, if you want to export all, you can. And that's actually what you're, did we do an export all on this, Tom, or is this copper only?
This is an export all.
This is an export all. Oh, that's right, because you do see the components on there as well. So that's the result when we export everything.
Yeah, I made the circuit board transparent.
Yep. So there are the options that you have if you really need to push something over that's not being pushed through on the connector side. Okay, so there you go. I'll press done here. And let me jump back over to my slide deck here. Okay. So what we want to do here is just take a couple of minutes to look at some of the questions that you have. And so Tom's going to take a look at them. Also, Christopher Che, who is the man behind the curtain, has been looking at them as well. He may call out a couple of them as well if he sees ones that we should answer because maybe we glossed over something or need to clarify something as well. While they're doing that, just a little introduction to us here at 9.Connects. We know that you're here for a reason, and in this particular case, you're looking for a better way to handle your ECAD and your MCAD integration, and that you're also investigating options out there, and that there's options that are coming out all the time, and it's a good thing, right? Because this ECAD and collaboration really needs to happen in a much easier way. So who are we here at 9.Connects? We are a PCB-centric organization, but more importantly, we also now have a focus on mechatronics design. So yes, we believe in the electronics world, the PCB is the medium of all mediums, but at the end of the day, it's got to be a part of the real world, and that there requires a mechanical element of it as well. So what do we do to support this? Well, there's 4 things. First and foremost, we have our products. So the connector is one of the ones that we do provide. So if you're interested in that, let us know. But the thing that we want to emphasize is that when you buy something with us, it's not just an end at the point of sale, it's really the beginning. Because at that point, we're here to support you on it. We're not going to kick you over to SolidWorks support if you have an issue. We want to look at it first, and if we can't figure it out, then we will go together with you to SolidWorks support so that we can learn about it as well. For training, we do teach on a number of different tools, not only for SolidWorks PCB, but also for Altium Designer, also various concepts within Altium Designer, for example, configuration management or SPICE or Vault. Those are things that we can assist with as well. We also have our services. So what we mean by services are well-defined tasks. So if there's something very specific that you want us to do, it's like, hey, design this for us or lay this out for us. As long as we know what the parameters are, we can fix bid that as a service. There are certain things that also people come to us, they come with napkin drawings, they have ideas, or maybe they're in the middle of something and they're just not really sure where to go with it. We also provide consulting as well. And that's just so that we can provide service where you need it, and we can make our hours and time available to you as necessary so that you complete the project there. So those are the things that we do provide here at 9.Connects. And then, of course, lastly, if you want any more information about us, please do check out our website. There's a lot of information that we're always trying to put up there, and there'll be a lot more as we dig deeper into our relationship with SolidWorks here. So do look on our top ribbon, because we do have a whole section now for SolidWorks PCB, and trust me, there's a lot more that we plan on adding to that as time goes on. So with that, we'd like to answer a couple of the questions there. Tom, I don't know if you had an opportunity to take a look at any. And then Christopher, if you want to jump in there too, let me know. So I'll pull this up here.
Paul, let's do that last polling, if you don't mind.
Oh, yes, let's do that. I'm sorry about that. Let's definitely initiate that last poll.
Thanks a lot, and that adjourns our webinar for the month. Thanks.